This is my predicted paper for paper 3 foundation on the 10th of June, just based on what's already come up on paper 1 and paper 2. Obviously it's no guarantee, but it's just going to cover a lot of the common topics that we haven't seen yet. So here we go. Question number 1, write down the value of the 3 in the number 2315. So that 3 is in the hundreds column. It is therefore worth 300. So you can either write 300 like that, or 300s would be absolutely fine. The one thing I will say is don't just write hundreds on its own. Yes, it's in the hundreds column, but it has a value of 300, so we need to write 300 there. For question number 2, write 0.4 as a fraction. Give your answer in its simplest form. So 0.4 has a 4 in the tenths column, so it is 4 tenths, or you could think of it as 4 divided by 10. And then we want to simplify that. Give your answer in its simplest form. Well, both of those numbers are divisible by 2. So we're going to divide the numerator by 2 and the denominator by 2, and that is 2/5 as my final answer there. For question number 3, round 34.785 to 2 decimal places. Well, 2 decimal places means 2 numbers after the decimal point. So this is your first decimal place, this is your second decimal place. We therefore want to check the next number, which is a 5, and 5 rounds up. 5 and above rounds up, 4 and below rounds down. So that rounds up and turns this number into a 9, 34.79. Question number 4, work out 2/7 of 28. Now you have a calculator, so you can just type this in your calculator. Or remember that when we do a fraction of a number, we divide by the bottom and then take that answer and multiply it by the top. If you want 2/7 of a number, you are splitting the number into 7 equal parts and then saying, I want 2 of them. So 28 divided by 7 is 4. So each of these sections would be worth 4. And then you want 2/7, so you want 2 of those sections. 4 times 2 is 8. Question number 5, if we are solving an equation, I like to put a dotted line where the equals is. What we do to one side, we're going to do to the other. I would just like to know what x is, so I want to get that x on its own. In order to get x on its own, I need to add 7, because adding 7 is the inverse of subtracting 7. But if I add 7 on one side, I also need to add 7 on this side. So x equals 10 is my answer there. Question number 6. Here is a list of numbers. We've got 10, 11, 12, 13, 14, 15, 16. From the list, write down a factor of 20. So factors are numbers that fit in an exact number of times. A factor of 20 here is going to be 10, because 10 fits into 20 2 whole times. So 20 is in the 10 times table, 10 fits into 20, it's a factor of 20. A prime number, and we've got 2 here that we could pick from. A prime number is a number that only has 2 factors, 1 and itself. So it's only going to be in the 1 times table and its own times table. And for that you could pick 11 or 13. Either of those would be absolutely fine there. I'm going to go for 13, why not? And then a square number. So 1 times 1 is 1. 2 times 2 is 4, 3 times 3 is 9. These are your square numbers here. 4 times 4 is 16, so that was the one we were looking for. 16 from the list above up there. Question number 7, write down the mathematical name of quadrilateral A. So this is a parallelogram. There are a few good ones to know. We've got trapeziums that look a bit like this. You've got a rhombus, which is when all 4 sides are the same length. Parallelogram, that's our pushed over rectangle. And then we've got, what else? Kite. And then there's 3D shapes that you might need to know as well, but those are the 2D ones that I would make sure you know. Reflect shape A in the mirror line. So we want to make sure that we're the same distance away from the mirror line on both sides. So where this point here is 1 square away, it's going to be 1 square away on this side. Same down here. And this one is 4 squares away, so it's going to go up here. And this one is here. And then I would just join them up. It's just a little bit easier to do the points and then join them up than it is to try and reflect the shape. So there we go. Question number 8. Simplify 3a minus a, add 2a. So an a on its own is the same as 1a. If I have 3a and I take away 1a, I'm left with 2a. And then I'm going to add another 2a and that is 4a as my answer there. For part B, simplify 5p squared, add 3p squared. Well, altogether, I've got 8 lots of p squared. That power does not increase. If you add p squared times p squared, that would be p to the power of 4. If you're multiplying, then you're going to increase that power. But because we are adding, we're collecting up, I've got a p squared and some more p squareds. Altogether, I've got 8p squared. And for part C, I've got 12 minus 5c, add 2b, add 3c minus b. So first, the 12 has to stay on its own. There are no other constant terms, just numbers on their own. So that needs to stay as it is. Then I've got minus 5c, add 3c. Now think about your number line. If you are at minus 5 and you add 3, you're going to go this way, and you'd go minus 4, minus 3, minus 2 is where you'd get to. So I've got minus 2c, and then I've got positive 2b, take away 1b. If you're at positive 2 and you take away 1, you're left with positive 1b. You can write 1b if you like that, but I'm just going to write plus b because we know that that means 1b. So final answer, 12 minus 2c, add b. Question number 9. ACD is a straight line. Work out the size of angle BAC. Give a reason for each stage of your working. So I'm going to pop an angle here and just say that this is x. This is what we're trying to work out. Let's start by looking at these little lines here. So these little lines means that they are the same length, and that means that this triangle over here is an isosceles triangle. So I know that this angle up here would also be 29 degrees. 2 equal sides, 2 equal angles, and I'm going to say because base angles in an isosceles triangle are equal. And now there are a couple of different ways you could go from here. You could go to this angle and then go to this one and then add this up to 180, but I'm just going to go straight and look at this entire triangle as a whole, because I've got all the other angles inside that triangle. So I know that this one's 29. I know that this one is 102 and 29 combined. So if I do 102 add 29, I get 131, and that's going to be all of this angle up here. So I've now got 131 add this 29, which gives me 160, and that means that I'm left over here with 20 degrees. So 180 take away 160 is 20 degrees. What reason have we used there? Well, we've used the angles in a triangle add up to 180 degrees. There we go. So 20 degrees, that's my final answer. Angle BAC, it was this one down here that we were looking for. Perfect. Question number 10. There are only red and blue counters in a bag. The number of red counters to blue counters are in the ratio 2 to 3. So whenever I see ratio, I do like to draw them out. I just think it's a bit easier to visualise. Work out what percentage of counters in the bag are red. Well, red was our first word and blue was our second word. So this means that this side is red and this side is blue. What fraction is red? Let's start with that. So red is 2 parts out of 5 parts altogether. And if I want that as a percentage, I can just times it by 100. So typing that in my calculator, 2/5 times 100, and that gives me 40%. However, the other way I could do it is to say, well, I've got 2 out of 5 at the minute. If I want it as a percentage, I want to make it out of 100. If you multiply the bottom by 20, which is what we would need to times it by to go from 5 to 100, then I also need to multiply the top by 20. So 40 out of 100, and that also tells me that it's 40%. Question number 11. Here is a list of ingredients for making 12 scones. Now, if you're bored in your revision, I did actually take this recipe offline. So if you want to go and make some cheese scones, if you've got time, knock yourself out. There we go. This is for 12 scones. Henry wants to make 30 scones. Work out how much of each ingredient he needs. So I'm going to always recommend, if you find these questions difficult, I would always write out 6 scones, or half the recipe on the left, and double the recipe on the right. So 24 scones over here. If you find this difficult, because normally when they ask you for something, it's going to be some combination of half the recipe itself and double. In this case, they've asked for 30, so I could just use the recipe for 24, the recipe for 6, and add it together. Okay, so that would always be a really good thing to do if you are stuck. Half the recipe, double the recipe, and use that to help you. However, what I'm going to do here is say, well, if he wants to make 30 scones and the recipe is for 12, 30 divided by 12 is 2.5. So I need to take the recipe and make it 2.5 times bigger. It will get me 2.5 times more scones, which is what we want. Okay, so big divided by small there is going to tell me how much bigger to make that recipe. So I'm going to then do 450 times 2.5, 110 times 2.5, 240 times 2.5, and 200 times 2.5, and that's going to give me each of the amounts, which I can then put on the answer line down here. 450 times 2.5 is 1,125. Okay, 110 times 2.5 is 275. Cheese, 240 times 2.5 is 600, and milk, 200 times 2.5 is 500 mils. There we go. That's the recipe for 30 scones. If you do make some scones, please tag me in your pictures of them. I'd love to see. Right, question number 12. Work out 35% of 80. So for this, we've got a calculator. So you can just use that percentage button on your calculator, 35% times 80. Or you can say, well, 35% is 0.35. So you could do 0.35 times 80. Or if you prefer, we know that 10% would be 8, because to get 10% we divide by 10. 30% would be 3 of those, make it 3 times bigger, which is 24. And then to get 5%, we would take the 10% here and divide it by 2. So if 10% is 8, then 5% would be 4. To get 35%, I'm going to add those two values together. 35% is 28, but you can absolutely just do it like this. 28 would be my answer there.
Question number 13. Finn asked each of her friends to name their favourite hobby. The table below shows information about their answers. We've got knitting, cycling, swimming and drawing. So I'm going to start by adding all of these together. 12 add 8 add 11 add 5 is going to be 36. So when we add all of that together we get 36. Now we know that angles in a pie chart around a point add up to 360. So I'm going to take 360 and divide it equally between the 36 people that we asked, and that is 10 degrees. So I then need to multiply each section by 10 degrees to find out how much each section is worth. So that one times 10 times 10 times 10 times 10, we've got 120 degrees, 80 degrees, 110 degrees, and 50 degrees. So you take the total 360 and divide it by how many pieces of data there are, and just double check that does add up to 360. Okay, we're going to start by drawing the first one, which is knitting. So I'm going to put my protractor in the middle here, the center on the center, and I'm looking for the 0. So the 0 is starting facing up, and we can see that that 0 is here on the outside. For you it might be down here where I've got 180, but for me it's at the top. So I'm going to go round until I get to 120, and that is going to be there. So make a mark, move that protractor out of the way, and then get your ruler and join it up. So just like this. Okay, then I'm going to take my protractor again, turn it round, and we're going to start it where that section just finished. So I'm going to pop it here. I'm doing my best on the computer. Pop it here and measure the next section. And the next section is 80 degrees. So I'm going to get my pen again and go round to 80, make a little mark, move that protractor out of the way, and then use your ruler to join it up. And then do the same thing again. We're going to move that protractor round so that it starts where that section finished. So turning it round, we get this. Here is a bit accurate. And then we're going to measure round until we get to 110 degrees was the next section. So that's here. And then the last section is 50, and we can see, I think I've got 51, but we can see that that's okay for the last section as well. So move that out of the way, get your ruler, join it up, and then we need to just not forget to label those sections. So get your pen, and we know that that was knitting there, cycling there, swimming there, and you might have them in different orders, that's okay, but the size of them should be correct. There we go, knitting, cycling, swimming and drawing.
Question number 14. Anna is 5 years older than Beryl. Beryl is double the age of Callum. The total of Anna, Beryl and Callum's ages is 70 years. How old is Anna? Okay, so Anna is 5 years older than Beryl. So Anna is older than Beryl, but Beryl is double the age of Callum. So I think Callum's the youngest here. So I'm going to go Callum, and we're going to say that he is X years old. Beryl then is double the age of Callum. So she's going to be 2x, 2 lots of x. Anna is 5 years older than Beryl. So for Anna, it's going to be the 2x add 5 because she's 5 years older than Beryl. So we need to take Beryl's 2x and add 5 to it. The total of their ages is 70. So x add 2x add 2x add 5 equals 70. I know that that is true. They've told me the answer is 70. So x, 2x and 2x. Remember, this is 1x. So in total here we have 5x, add 5 from here, equals 70. And then we're going to solve this equation. So let's take 5 away from both sides. 5x is 65. And then divide that by 5. If 5 lots of x is 65, then 1 lot of x is 13. So x is 13, but they've not asked me what x is. That would be Callum's age. X is 13 here. Beryl would be double that, so 26. Anna is double it and add 5. So she is 31 years old, and 31 would be my answer there. Part B says, what is the range of Anna, Beryl and Callum's ages? So the range is the biggest, take away the smallest. So the biggest is Anna, 31. Take away the smallest, which is Callum, 13. 31, take away 13 is 18. So 18 is the answer there for the range of their ages. The range is the biggest, take away smallest. Mode is the most common, median's in the middle, and what one haven't I done? Mean is when you add them all up and divide by how many there are. So, question number 15. Liz is working in a shoe shop. She arrives to work at 8:45 a.m. She spends 4 hours and 30 minutes helping customers on the shop floor. She then gets a 45-minute break for lunch. After her lunch, she then spends the rest of her shift tidying the stockroom until she leaves at 3:15. How long does she spend tidying the stockroom? Give your answer in minutes. Okay, so with these time calculation questions, I like to do a timeline. We're starting with 8:45. Now, it then says she spends 4 hours and 30 minutes. So we're going to add 4 hours first. And that's 9:45, 10:45, 11:45, 12:45. And then I'm going to add the half an hour. So 30 minutes. It would take 15 minutes to get to 1 o'clock. And then another 15 minutes. So half an hour after 12:45 is 1:15. So you've added 30 minutes on there. So in total, that's the amount of time she's helping customers on the shop floor. She then gets a 45-minute break for lunch. So we're going to now add 45 minutes. And adding 45 minutes takes me to 2 p.m. 45 minutes after 1:15. After her lunch, she then spends the rest of her shift tidying the stockroom until she leaves at 3:15. So she's leaving at 3:15. And this is the amount of time here that we're looking for. So from 2 o'clock to 3:15. And that is 1 hour and 15 minutes. But we're asked for our answer in just minutes. So 1 hour is 60 minutes. Add 15 minutes. So 75 minutes is our answer there for 3 marks. Question number 16. The diagram shows the positions of 3 points A, B and C on a map. The scale of the map is 1 centimetre, represents 4.5 kilometres in real life. On the map, the distance from A to C, so here, is 7 centimetres. Work out the real distance from A to C. So we know that 1 centimetre is 4.5 kilometres in real life. I've got 7 centimetres on the map, so I need to take my 4.5 and multiply it by 7 to find out how many kilometres that would be. And that is 31.5 kilometres. For part B, work out the bearing of B from C. Now the bearing of B from C means you are standing at C. If I go to school from my house, I am starting at my house. If I go to the shops from school, I'm starting at school, okay? So where it says from, that is where you are standing. From C, we're standing here. Now bearings start north and they go clockwise. So I want to know all the way round until I'm facing B. This is the part that I actually need. So I need all of these degrees. Now we know that angles around a point the whole way round add up to 360. So I'm going to do 360, take away 42, and that is going to be 318 degrees. That would be my answer. If you got a bearing less than 100, you do have to write a digit in front, 0 in front like that, 047. Bearings always have to have 3 digits. They always have to start north, and you always have to measure your angles going clockwise. Question number 17. A cafe sells tea or coffee. The prices are given below. A group of students buy 5 cups of tea and some cups of coffee. The total cost for the drinks is £37.50. Work out the number of cups of coffee the students bought. So we know they buy 5 cups of tea, so we can do £2.30 times by 5, and that gives us £2.30 times 5. That is £11.50. And then we know that the difference must be from the cups of coffee bought. So I'm then going to do £37.50, take away £11.50. which is £26. So I then just want to know how many cups of coffee is needed to make £26. So 26 divided by £3.25 will tell me how many cups of coffee were bought, and that is 8. Question number 18. There are only pink cubes, grey cubes and white cubes in a box. The table shows the probability of taking at random a pink cube from the box. The number of white cubes in the box is 4 times the number of grey cubes. Complete the table. So this one here, the number of white cubes, this is 4x and this is x. Or you can write it in the ratio 1 to 4. Either way, what we need to do here is work out what probability is left and divide it into 5 equal sections so that we can spread it between the grey and the white so that the white is 4 times bigger. So we know that probability adds up to 1. 1 take away 0.35 is 0.65. So I need to take 0.65 and share it over these piles. So 0.65 divided by 5 is 0.13. So if you think about that ratio, I've got 0.13 on each of those little lines, which means that grey is 0.13 and white is 0.13 times 4, so that is 0.52. The other way to do it is to say, well, together x and 4x is 5x, and 5x needs to equal 0.65. Dividing by 5, x is 0.13, and then you can work it out in the same way. We've completed the table there. Great. Question number 19. Here are the first 4 terms of a sequence. 2, 3, 8, 63. The rule to continue the sequence is square the previous term and then subtract 1. Work out the 5th term of the sequence. So from 2, we've squared it, which means times it by itself. That makes 4. Take away 1 gets us 3. 3 squared is 9. Take away 1 is 8. 8 squared is 64. Take away 1 is 63. So we now need to do 63 squared and then take away 1. Typing that in my calculator, 63 squared is 3,969. And then we want to take away 1, and that leaves us with a final answer of 3,968. I wouldn't want to carry on that sequence much more than that. Question number 20. Here is a triangular prism. Work out the volume of the prism. Give your answer correct to 3 significant figures. So volume is the area of the cross-section, volume of a prism, area of the cross-section multiplied by how far back it goes. So first thing I'm going to do is get the area of this triangle. And to work out the area of a triangle, we do base times height divided by 2. Don't forget to divide by 2. Area of a triangle is base times height divided by 2. So 0.9 times 1.3, all divided by 2. And that gives me 0.585. We're then going to take that answer and multiply it by how far back the prism goes. So multiply that by 11, because that's my depth, and that gives me an answer of 6.435 centimetres squared. For question number 21, a number h is rounded to 1 decimal place. The result is 2.1. Write down the error interval for h. So an error interval is saying the absolute biggest and the absolute smallest the number could have been before it was rounded. So if it's 2.1, it didn't round to 2.0 and it didn't round to 2.2. They both also have 1 decimal place. So we know that our original number is somewhere here in the middle, and we're looking for the smallest value it could have been. So that is going to be 2.05. If it had been any smaller than that, it would have rounded down. So 2.05 is the smallest, and we go the same amount above, 2.15 here. Now I know that technically 2.15 would round up, but 2.149 recurring is so infinitely close that we just use 2.15, 2.05, and at that top end, can you see here on our inequality symbols, we just don't have the equal to, because we know it can't actually equal that, it can just go infinitely close to it. That's your error interval. Question number 22. The frequency table gives information about the length of 45 fish. On the grid, draw a frequency polygon for the information in the table. So when we draw a frequency polygon, we want to go in the middle of the category and plot that frequency. So we're going between 0 and 5, so 2.5, and we're going up to 3. Now be really careful with your axes when it's got lots of little squares like this. Be careful, because this is 1, this is 2, this is 3, this is 4. So actually it's 2 squares for every 1. So when I'm wanting to plot a frequency of 3, I'm going to need to go to here, and then between 5 and 10, so we're going to go across to 7.5, we're going to go up to 9, which again is going to be 2 squares down, remember, because 2 squares is 1. We're going to go between 10 and 15 and up to 12, so that's going to be there, and then 15 to 20 up to 15, and 20 to 25, so going in the middle, and we're going up to 6. So just make sure you've plotted those in the correct places. Join them up with lines, and you might have heard me refer to this one as Polly the shark. So normally it makes that kind of shark fin shape. Polly the shark, she lives in the middle of the ocean, that's how we're going to remember it, and we do not join her up to the shore. Don't join her to the origin, because she likes to be a free shark in the middle of the ocean. There we go. So middle of the category for that one, dot to dot, join them up. Makes a little bit of a shark fin shape. Question number 2, standard form. Write 534,000 in standard form. So for standard form, we need a number between 1 and 10. So the digits here that we need would be 5.34. And then we're going to times that by 10 to the power of something. Now 534000. If we want to multiply 5.34 to get 534,000, how many times would we need to move that over? And the easiest way to do it is to move the decimal point. It's not the decimal point moving, but it's the easiest way of counting the place value column. So 1, 2, 3, 4, 5. The decimal point at the minute is here, and we want it to be there between the 5 and the 3. So although it's all the digits that are moving, that's the quickest way to count. So 5.34 times 10 to the power of 5. For part B, write 9.8 times 10 to the power of minus 7 as an ordinary number. With that negative power, that means we are dividing by 10, dividing by 10, dividing by 10, 7 times. So 5, 6, 7. The decimal point is going to be here. 0.0000000, and with the negative ones it is always going to be the number of zeros, including that one in front of the point, but always good to double check, because that isn't the case when the power is positive. 1, 2, 3, 4, 5, 6, 7, 0.98. There we go. So that only works for the negative, but always a good idea to draw it out. For part C, I'm just going to type this in my calculator exactly as it is there. So brackets 3.08 times 10 to the power of -3. Close the bracket and then times that by another bracket 1.92 times 10 to the power of 6. Shut that bracket and then hit equals, and in my calculator I get 5913.6, but I've been asked to write it in standard form, correct to 3 significant figures. So first let's do our rounding. 1, 2, 3 significant figures is going to be 5,910. because the 3 would round down. And then we've got to write that in standard form. So that's going to be 5.91 times 10 to the power of 3, because we want the decimal point to be here. 1, 2, 3. There we go. 5.91 times 10 to the power of 3, rounded to 3 significant figures. Question number 3. Shown below are a circle and a rectangle. The circumference of a circle is equal to the perimeter of the rectangle. Calculate the value of x. So our circumference is found by doing 2 pi r, or you might know it as pi d. But either way, we're going to need to take this radius, double it, and multiply it by pi. So 48 times 2 gives us a diameter of 96, and so it's 96 pi. Multiply that by pi, and we get 301.5928947 centimetres. Okay, that is the circumference of the circle. Now I'm going to move over to the perimeter of the rectangle, and I've got this length in metres, so I'm going to convert it to centimetres. Now I would do that by multiplying by 100, and that means that this side over here is also 120 centimetres, and this side over here is x. So I know that for the perimeter of this rectangle, it would be 120, add x, add 120, add x. So I can add these together and get 240, and then we know that these two are equal. So we know 240 add 2x equals 301.59, this number here. So I'm going to take 240 away from 301.59. That gives me 61.59. So 2x equals 61.59289. And then we're going to take that answer and divide it by 2. 30.79. 644, and we'll round that to 1 decimal place. So 30.8 would be our answer there. Question number 4. The probability tree diagram shows the probability that it will rain on Monday and Tuesday. Calculate the probability that it will rain on at least one of these 2 days. Okay, so at least one day means we want it to rain on either one or both days. So we want rain, rain, or we want rain, not rain, or we want not rain, rain. But the only one we're not interested in is this bottom pathway. So we don't want not rain, not rain. Now to work out the probabilities, we multiply along the branches and then add the ones we want. So 0.34 times 0.2, that would get us the probability of it raining on Monday and on Tuesday. For the second pathway, we've got 0.34 times 0.8. For the third pathway, we've got 0.66 times 0.2. And for the fourth pathway, the one we don't want, if we wanted to work that out, it would be 0.66 times 0.8. And what we're going to do, because we want these 3 pathways, we're going to calculate these 3 and add it together. So 0.34 times 0.2 is going to be 0.068. 0.34 times 0.8 is going to be 0.272. And 0.66 times 0.2 gives us an answer of 0.132. We can then add those 3 answers together to get the total probability of it raining on at least one day. So let's add those up, just using my calculator to do that. And that gives me an answer of 0.472. So 0.068, add 0.272, add 0.132, is 0.472. Now you might have spotted that there is a quicker way. So instead of adding those 3 pathways up, because probability always adds up to 1, if I'd calculated that 4th route, I would have got 0.528. 0.66 times 0.8. Now, because that's the only one I don't want, if I'd have done 1, which we know is what these will all add up to, take away 0.528, I would have got 0.472. So that would have also got me the correct answer. So you'd be fine to do it that way, work out what you don't want and take it away from 1. So always with probability, remember to multiply along the branches and add the ones you want. There we go, 0.472. Question number 5, ABCDEF is a hexagon. Angle CDE, so this one here, is 3 times bigger, so I'm going to put 3x, than angle BCD, this one here. So let's call that one 3x and that one x. Work out the size of angle CDE. Well, we know that angles in a hexagon, to work that out, it's a 6-sided shape. To work out the number of degrees inside a shape, we're going to do the number of sides, take away 2, times by 180. That is your formula. So because this is a 6-sided shape, a hexagon, that's going to be our value of n. So 6 take away 2 is 4 times 180, which is going to be 720 degrees. So the angles inside this shape, the interior angles, need to add up to 720. I'm going to start by adding together what we already know. 112, add 169, add 110, add 105. Let's add those 4 values together. 112, add 169, add 110, add 105. That adds up to 496. And I then need to take that away from 720. We could set up an equation here. We could say that we know 496 add these ones, 3x add x, needs to equal 720. And this is just 4 lots of x altogether. I'm going to start by taking 496 away from both sides. So 720 minus 496 is 224. So 4x needs to equal 224. Let's then divide that by 4. And that gives us a value that x is 56 degrees. So x is 56, but they did not ask us that. They asked us for the value of EDC or CDE. So we need to multiply that by 3. 3 lots of 56, this angle here, is 168. So our final answer on the answer line is 168 degrees. Question number 6. There are 12 pencils in a packet. Caleb has 5 packets of pencils. He also has 6 extra pencils. Write the number of pencils in one packet to the total number of pencils Caleb has. Give your answer in the form 1 to n. So there's 12 pencils in a packet and he's got 5 packets. So 12 times 5 means he's got 60, but he's also got 6 extra. So if we add on 6, we've got 66 in total. It says write the number of pencils in one packet, so that's 12, to the total number of pencils Caleb has. So that's going to be 66 on this side. Give your answer in the form 1 to n. Now we need this side to be 1. So to do that, we need to divide by 12. And if I've divided that side by 12 to keep this ratio equivalent, I'm also going to divide this side by 12. 66 divided by 12 is 5.5. So we're not usually allowed to use decimals in ratios, but if it says the left-hand side or the right-hand side has to be 1, then the other side needs to be whatever it needs to be. So in this case, it had to be 5.5 to keep it equivalent. Okay, question number 7. Hamish cooked 20 cakes. The total cost of making the cakes was £20.45. Hamish sold the 20 cakes for £3.50 each. Calculate the percentage profit Hamish made on the cakes. So £3.50 multiplied by 20 is going to be the amount of money that he got all together, and that is £70. Now calculate the percentage profit. So for profit, we want the extra money out of the original times by 100. So a bit like percentage change, it's going to be that change over the original times by 100, or the extra over the original times by 100. Now to get the change, we need to do 70, take away £20.45. How much profit did he actually make? Okay, we've got to take away the cost out of the original, so out of what he spent out in the first place, times by 100. And I am just going to type that in my calculator. So for the numerator, 70 take away 20.45 out of 20.45, and we're going to times that by 100, and that gives us an answer of 242.298. So round that to one decimal place, 242.3%. There we go. So that was the percentage profit he made. A good little investment, I would say. There we go. Question number 29, expand and simplify. So we're going to do the first multiplied with the first with the second with the first, second with the second. So you might know that as FOIL. First, outer, inner, last. So multiplying the first with the first thing in each brackets, is 3x times x, and that is 3x squared. Then I'm going to do the outer, which is 3x times minus 2, so minus 6x. The inner, which is 2 times x. And 2 times minus 2, which is the last thing in each brackets times together, minus 4. Collecting up my like terms here, if I've got minus 6x, add 2x, that's minus 4x. So 3x squared minus 4x minus 4. You also might like to do that in a table. So 3x add 2 and x minus 2, and we're multiplying together. And then just filling out the table, we've got 3x squared, 2x minus 6x, and minus 4. And then all these terms come together to be your answer. Part B, factorise x squared, add 10x, add 25. So when we factorise, we're looking for a common factor. Factorise means to put into brackets. So normally, if I was given something like x squared add 10x, I would say, well, they've got x in common. And I would take that x outside a bracket and be left with x add 10. But here, this term has x in it, this term has x in it, but this one doesn't. And that's our sign that this needs to factorise into 2 brackets. So to do that, we're looking for 2 numbers that add to make the number in front of x and multiply to make the number here, the constant term. So I'm going to write, it could be 1 times 25, or it could be 5 times 5. Those are the numbers that multiply to make 25, the factors of 25. And we need 2 numbers that also add to make 10. So that's going to be the 5 and the 5. So I'm going to put x add 5 in this bracket and x add 5 in this bracket. You could also, if you want, write that as x add 5 squared. That would be fine for the marks as well. Part C, factorise fully. Now this one is going to go into one bracket, and that's because they have things in common. So they're both in the 5 times table. They both have an x and they both have a y. What would I need to multiply 5xy by to get 10x squared y? Well, it would be a 2 and an x. Add, and then 25xy squared, I'm going to need to multiply by 5. I've already got the x, but I do need y squared more. And then if you did this times this and this times this, you would get what we've got up here. So we're working backwards there. 5xy on the outside, 2x add 5y squared inside the bracket. Okay, last but not least, question number 30. Work out the length of AB. Give your answer correct to 1 decimal place. This is a right angled triangle and we've got an angle involved, so this is going to be SOHCAHTOA. So let me write down SO, CA, and TOA. First thing we want to do is label our sides. So starting at the right angle and going over, this side over here, this is my hypotenuse. And then we want to go to the angle we're interested in and go over from there. That's your opposite. And this next to that angle you're interested in is the adjacent. And then we need to think, right, what is involved? So we want to know AB. This is the side we want to work out. And this one, we know how long it is. We have that helpful information. With the adjacent, I don't know how long it is, and I don't really want to know how long it is for this question. So there we go. We're left with O and H, which tells me to use SO. Now, in that SO triangle, the S stands for sine of the angle, so sine 37. If we were using CA, it would be cos 37. If we were using TOA, it would be tan 37. The O is the opposite, so that's 12.4. And the hypotenuse is what we're trying to work out. Cover up the thing you want to know and do the sum that's left behind. So we're left with O divided by S, which is 12.4 divided by sine 37. I can then put that in my calculator. 12.4 divided by sine 37, and that gives me an answer of 20.60433. So 1 decimal place would be 20.60433. 6 centimetres for that side. And that is it, all 80 marks. I hope you've enjoyed it. Please let me know in the comments if you've got any questions or how you got on. I'd love to know. It'd be great to hear from you. And good luck for paper 3.